Hello judges, we are team Jai Hind from IIT Patna and we are tackling problem statement 3 for Union Bank of India, tracking of funds within bank for fraud detection. Today, financial criminals move money across complex multi-layered accounts in seconds, but investigators are forced to track them using traditional relational SQL databases, starting at flat, row, and column. This tabular approach makes it nearly impossible to spot circular transaction, rapid layering, or smurfing, resulting in massive revenue leakage and regulatory AML penalties. Our solution is FinTrace, an intelligent full-stack fund flow analyzer. FinTrace completely shifts the paradigm from searching tabular data to visualizing relationships. Instead of relying on basic rule-based triggers, FinTrace relies on four innovative pillars: graph-based relation mapping, autonomous topology detection using ML, dynamic behavioral profiling against KYC data, and one-link FIU evidence packager. Here is how it works under the hood. First, our Node.js pipeline injects multi-channel banking logs, but instead of storing them in flat tables, we map the entire banking ecosystem into Neo4j, a purpose-built data graph database. We treat every bank account as a node and every transaction as directed edge. This allows us to track 5 hop transactions in milliseconds. Let's see FinTrace in action. Welcome to the FinTrace admin dashboard. Immediately, investors get a real-time pulse of the network. Our synthetic pipeline has processed over 12,400 transactions successfully, detecting 47 fraudulent anomalies with a 99.6% success rate. But rather than just showing historical data, we want to prove our ML engine works live. This is a live ML risk analyzer. It interfaces directly with a Python fast API backend holding our anomaly detection model. Let's run live assessment. I am going to input synthetic dataset for account ID ACC001. As you can see, model successfully evaluated the features. It returned a low risk status with 34% fraud probability and generated an automated natural language explanation of the anomaly score. This proves our end-to-end AI pipeline is fully functional. We also get the performance metrics and recent security alerts in the dashboard itself. Let's move to alert section. When our ML model flags an anomaly outside of a defined threshold, it routes directly to the fraud alerts queue. Here, investors see exactly why a transaction was stopped. If an investigator needs to see the raw ledger, our transaction history page pulls directly from our database. It shows the real-time status of an online transaction, ATM withdrawals, and declined payments. Notice how TXN001 from the flagged account is logged here seamlessly. The core difference is a graph visualization. While tabular logs are great, the true innovation of FinTrace is our Neo4j graph investigator. Let's look at the transaction network visualization. Traditional databases would require complex, slow SQL joins to track money moving from account A to account B to account C. By modeling accounts as nodes and transactions as edges, our system plots the exact trajectory of funds instantly. Here you can visualize, see the risk distribution. Nodes 002, 004, and 006 are flagged in red as critical. If this were a smurfing or round tripping attack, the investigators would see the visual loop forming right here on the screen, cutting investigation time from hours to seconds. To support bank management, our report and analytics dashboard aggregates this graph and ML model into a 7-day transaction trend. It clears breaks down the account risk distribution, showing exactly how many accounts sit in the critical high and medium threshold. Finally, detecting fraud is only half the battle, reporting it to the other. Union Bank must comply with the RBI regulation. Our FIU export center bridges this gap. With a single click, investigators can export the visual graph, transaction chains, and an ML anomaly explanation into a standardized PDF evidence package or a CSV ready for immediate submission to the financial intelligence unit. Front end. We know enterprise banking requires reality checks. We have anticipated the challenge, massive data volume, and alert fatigue. To mitigate this, FinTrace uses asynchronous batch processing to save heavy compute for flagged thresholds. We also deploy a human-in-the-loop feedback system where investigator actions continuously retain our ML model to reduce false positive over time. The impact here is massive. For investigators, we transform manual log readings into visual, AI-assisted tracking. Economically, we shield public sector banks from massive regulatory penalties. Socially, we actively disrupt the financial network that fraud organized crime. For this proof of concept MVP, we have successfully built the end-to-end pipeline, the synthetic data generator, the new 4G graph construction, the Python ML detection engine, and the functional React dashboard for our planned phase 2 and 3 production release. Our methodologies are directly backed by the Reserve Bank of India AML directives and FATF topologies. We are Team Jahan and we believe Fintrace is the future of secure banking. Thank you for your time.